Hi guys, this is Manohar and welcome to Tutoralz. Today in this video, we are going to discuss about the topic pipes and cisterns. Actually, the concept behind the pipes and cisterns and time and work is exactly same, and we use the same methods that we followed in the time and work to solve the problems. Okay, so if you haven't watched the time and work tutorial, I recommend you to please watch time and work tutorial before watching this pipes and cisterns, so that you can understand what are the concept of pipes and cisterns and also time and work, and also what are the methods we use to solve the problems. Okay, now let's see what is the basic difference between time and work and also pipes and cisterns. The concept is almost same, but there is a minor difference between them. Suppose assume that in time and work, two persons are involved in the work. Okay, in time and work, two persons are involved in the work. So two persons always try to complete the work. Okay, but in pipes and cisterns, if two persons are involved in the work, one person try to complete the work and one person try to remove the work that has already done. So I will consider some examples so that you can understand in a better way. Okay, suppose assume that there is a pipe called P. There is a pipe called P that takes 10 hours to fill the tank. Suppose assume that there is a tank here. Okay, there is a tank here. So P takes 10 hours to fill the entire tank. Okay, so since P is filling in 10 hours, P's 1 hour's efficiency or 1 hour's work is 1 by 10. Okay, since P is taking 10 hours to fill the entire tank, P's efficiency or 1 hour's work is 1 by 10. Okay, suppose assume that for this entire tank, there is a minor tap here. Okay, for the tank, there is a tap here. So, tap can empty the whole tank in 20 hours. Okay, so P is taking 10 hours to fill the entire tank. But suppose assume that there is a tap for entire tank. This tap can empty all the water in the tank in 20 hours. Okay, suppose if the tap is opened, then a tap can complete the whole water in the tank in 20 hours. Okay, since Q is completing the total water in the tank in 20 hours, Q's 1 hour work or Q's efficiency will be 1 by 20. Okay, here you can understand the difference. P is trying to fill the tank and Q is trying to empty the tank. Okay, because Q is emptying the total water in the tank. Okay, now how can we say what is the total time taken if both of the taps are opened? Okay, suppose assume that this P is filling the tank and Q is emptying the tank simultaneously. Then what is the total time taken to fill the entire tank? So in the time and work, if two persons are working, we will add both the work together so that you can come to know what is the total time taken for them to complete the whole work. So we are using same method here. So to fill the tank, P plus Q are working together. So we can write it as to complete one part of work. Okay, here P and Q are working together to complete this one part of work, that is filling the tank. Okay, now P is trying to complete the work and Q is trying to remove the work. Okay, removing the work in the sense emptying the water in the tank. Okay, now P is trying to fill the tank. So we can write it as 1 by 10 plus here Q is trying to empty the tank, that is empty the whatever the work that was done by P. So we will write it as minus 1 by 20. Okay, here Q is trying to empty the water that was already filled by P. So we are writing this as negative in the total work done. Okay, now you have understood what is the basic difference between time and work and also is pipes and cistern. In pipes and cistern, one person is trying to fill the tank and one person trying to empty the tank. That's the reason we are keeping here negative symbol for the person whoever is trying to empty the work. Okay, now if I take this, we will come to know 1 by 10 minus 1 by 20 equal to 1. So if I take LCM, I will get 20 here and 2 minus 1, okay, equal to 1. So they can totally take 20 hours to complete the whole work, that is filling the tank. Okay, here suppose I will explain you once again so that you can understand in a better way. Okay, P is trying to fill the tank and the tank has a under tap that is emptying the water in the tank. Suppose if both P and Q are opened, we can say P is trying to fill the tank, that is 1 by 10, and Q is trying to empty the tank. That's the reason we are keeping the negative symbol for the Q's work. Okay, so we can simply say that 1 by 10 minus 1 by 20, the LCM will be 20 and 1 by 10 into 20 will be 2 minus 1, that is 1 by 20. So they totally takes 20 hours to complete the total tank. So this is the basic difference between the pipes and cisterns and also time and work. In time and work, two persons try to complete the work, but here P is trying to complete the work and Q is trying to empty the work that is done by P. Okay, actually this is the basic difference between them. So if we solve more problems, you can understand how to solve this problems based on this pipes and cisterns problems. Okay, now let's solve some basic level problems so that you can understand in a more better way. Now let's see the first problem. They are saying that if a pipe fills a tank in 6 hours, then what part of the tank will be filled in 2 hours? So we need to find out what is the part of tank that will be filled in 2 hours. Okay, so they are saying that if a pipe fills a tank, so pipe fills a tank in 6 hours. So pipe's 1 hour work will be 1 by 6. Okay, now they are asking us to find out what is the part of the tank that will be completed after 2 hours. Okay, so 1 hour work will be 1 by 6, so we can simply write 1 by 6 into 2, that is 2 ones, 2 threes. So 1 by 3 part of the tank will be completed after 2 hours. Okay, now let's see the second problem. They are saying that an outlet pipe can empty the cistern in 3 hours. In what time will the pipe empty 2/3 part of the cistern? So we need to find out what is the total time taken for P to complete the 2/3 part of the cistern. Okay, now they are saying that an outlet pipe can empty the cistern in 3 hours. So 1 hour's work or efficiency will be 1 by 3. Okay, now they are asking us to find out to empty the 2/3 part of the cistern. Okay, so this is the time taken for complete one part of the cistern, but they are asking that 2/3 part of the cistern. So 1 by 3 into, we don't know how much time taken, so I am considering it as x hours. Okay, to complete 2 by 3 part of the cistern. So we can simply say 3 will be cancelled and x will be 2 hours. Okay, see here they are asking us to find out only 2/3 part of the cistern. So for one part of cistern totally takes 3 hours to complete the cistern. Then they are asking us to find out 2/3 part, that is 1 by 3 into, we don't know what is the total time taken, so I am considering it as x. Now to complete totally 2 by 3 part of the work, so we can simply say x equal to 2 hours. Now let's see the third problem. They are saying that a tap can fill a cistern in 8 hours and another can empty it in 16 hours. If both taps are open simultaneously, the time taken to fill the entire tank. So we need to find out what is the total time taken to fill the entire tank. So here one tap is trying to fill the tank and another tap is trying to empty the tank. Okay, now this problem can be solved in both normal and also LCM or units method. So if you have watched the time and work tutorial, you have came to know what is the LCM or units method and also normal method. Okay, so I will solve in both the methods so that you can understand how to solve this pipes and cistern problems also in LCM or units method. Okay, now I try to solve in both the methods. One is normal method and one is LCM or units method. Okay, now they are saying that a tap can fill the entire tank in 8 hours. So P's 1 hour work or P's efficiency will be 1 by 8. And also they are saying that under tap can empty the entire tank in 16 hours. So Q's 1 hour work or efficiency will be 1 by 16. So they are saying P is trying to fill the tank and Q is trying to empty the tank. So if both taps are open together, we will keep negative sign to the Q, because Q is trying to empty the tank, that is removing the work that has done by P. Okay, so if both tanks are open together, P plus Q are trying to fill the tank, that is one part of work. So the efficiency of P is 1 by 8 plus, since Q is trying to remove the work that has done by Q, that has done by P, I am keeping negative sign for the Q's work. Okay, since Q is trying to remove the entire water in the tank, that is removing the work that has done by P, that's the reason I am keeping negative sign for the Q. So I will get 1 by 8 minus 1 by 16 equal to 1, and the LCM will be 16, and 1 by 8 into 16 will be 2 minus 1 by 16 into 16 will be 1, that is 1 by 16. So totally takes 16 hours to fill the entire tank. Now let's see how LCM or units method works in solving the same problem. See, they are saying that P can fill the tank in 8 hours and Q can empty the tank in 16 hours. Okay. So the LCM of 8 and 16 will be 16 units. that is the total amount of work to be done is 16 units. So P is doing 16 units of work in 8 hours. So per hour P is completing 16 by 8, that is 2 units of work. Okay, and also Q is completing 16 units of work in 16 hours. So per hour Q is completing 16 by 16, that is 1 unit of work. Okay, per hour P is completing 2 units of work and per hour Q is removing 1 unit of work. So if both are open together, that is P minus Q. Since Q is removing the work, I am keeping negative sign for Q. So P minus Q is equal to 2 minus 1, that is 1 unit per hour. So if both tabs are open together, they can fill only 1 unit per hour. So to fill this 60 units of work, they will take 16 by 1, that is 16 hours to complete the work. Okay, here whenever the problem says one tap is removing the work or emptying the tank, we will keep negative sign for that, so that we can come to know what is the total amount of work that is left after emptying the work. Now let's see the fourth problem. They are saying that a water tank is 2/3 full. Pipe A can fill the tank in 10 minutes and pipe B will empty the tank in 6 minutes. If both pipes are open, how long will it take to empty or fill the tank? So we need to find out what is the total time taken, whether to empty the tank or fill the tank. Okay, now they are saying a water tank is only 2/3 full. Here tank is not completely full, it is only 2/3 full. Okay, and also they are saying A can fill the tank in 10 minutes. So A's 1 minute work or efficiency will be 1 by 10. And B can empty the tank in 6 minutes. So B's 1 minute work or efficiency will be 1 by 6. Okay, now we need to find out whether it is to fill the tank or empty the tank. First of all, we need to find what is the total time taken for them to complete the entire part of the tank. Then we can find out whether it is to fill the tank or empty the tank. Okay, now I am finding what is the total time taken for A and B if they open simultaneously to fill the tank. So I am adding both the efficiencies. So I will get 1 by 10 minus 1 by 6 equal to 1. Since B is removing the work, I am keeping negative symbol for the B's efficiency. So I will get the LCM of 10 and 6 will be 6 3 is 18, 24 and 36 was 30. 30 will be divisible by 10 and 6. Yeah, 30 units is the LCM and 1 by 10 into 30 will be 3 minus 1 by 6 into 30 will be 5. That is minus 2 by 30. That is 2 ones, 2 15s, minus 1 by 15. Here we have got negative symbol. In the sense they both take 15 minutes to empty the tank. Okay, here we have got negative symbol, so they can remove the entire tank in 15 minutes. Okay, that is 1 minute 1 by 15. So for whole the tank they will take 15 minutes. Okay, to empty the whole tank they will take 15 minutes, but to empty the 2 by 3 tank they totally take, suppose assume it is as x. So x equal to 2 by 3 into 15. That is 3 ones, 3 5s, 2 into 5 will be 10 minutes. So they totally takes 10 minutes to empty the tank but not to fill the tank, because we have got negative sign here. In the sense they take 15 minutes to empty the whole tank. To empty the 2 by 3 fill tank they will take 10 minutes. Okay, now let's see how LCM or units method works for the same problem to complete this. Okay, so they are saying A takes 10 minutes to fill the tank and B takes 6 minutes to empty the tank. So here minutes, here units. Okay, so the LCM of 10 and 6 will be 30 units. So this is the total amount of work to be done. Okay, now A is completing 30 units of work in 10 minutes. That is A is completing 30 by 10, that is 3 units of work per minute. Okay, B is completing 30 by 6, that is 5 units per minute. Okay, now if I add this both the works, I will come to know what is the total amount of work done per minute. Okay, so if I add both the A plus B, I will get, since B is removing the work, I am keeping the negative symbol for the B's work. Okay, since B is removing the work, I am keeping negative symbol for the B's work. So I will get 3 minus 5, that is 2 units minus 2 units. So they are emptying 2 units of work per minute. Okay, so to empty 2 by 3 fill tank, okay, here the total amount of work to be done is 30 units. So 2 by 3 of 30 minutes will be 2 by 3 into 30 minutes, that is 3 ones 3 tens equal to 20 units of work. So here totally 20 units of work is already done. So to empty this 20 units of work, they will take 20 by 2, that is 10 minutes of time. Okay, here A plus B can empty 2 units of work per minute. So we already know the tank is only 2 by 3rd fill. So 2 by 3rd into total work to be done, that is 20 units of work is need to be emptied. So per minute they are emptying 2 units of work. So to empty this 20 units of work, they totally take 10 minutes of time. Okay. Now let's see the fifth problem. They are saying that if 3 taps are opened together, a tank is filled in 12 hours. One of the taps can fill it in 10 hours and another in 15 hours. How many hours does the third tap take alone to empty the completely? So we need to find out what is the total time taken by third tap to empty the total tank. Okay. Now they are saying that if 3 taps are opened together, that is A, B and C, they can fill the tank in 12 hours. That is 1 hour work will be 1 by 12. Okay. And also they are saying one of the tap can fill the entire tank in 10 hours. So 1 hour work will be 1 by 10. And another tap can fill the tank in 15 hours. So the 1 hour's work will be 1 by 15. Okay. Now we need to find out what is the total time taken for third tap to empty the tank. Okay. Here C is emptying the tank. So we will keep negative sign for this C in the problem. Okay. Now I need to find out what is the total time taken for C to empty the tank. Now I am substituting this both values here so that I can come to know what is the C's efficiency or C's total time taken to empty the tank. Okay. Now if I substitute all these values, I will get 1 by 10 plus 1 by 15. Since C is empty in the tank, I am keeping negative sign for the C. So 1 by 12. Okay. Since C is empty in the tank, I am keeping negative sign for the C. So I will get, if I send this 1 by 10 and 1 by 15 to the right hand side, or if I send this C to the right hand side and 1 by 12 to the left hand side, I will come to know what is the total time taken for C to empty the tank. Okay. So I am sending this C to the right hand side and 1 by 12 to the left hand side. I will get 1 by 10 plus 1 by 15 minus 1 by 12 equal to C. Okay. So the LCM of 10, 15 and 12, that is 12 3s, 12 4s, 12 5s, 60 and 15 4, 60, 10, yeah, 60 units. So I will get 1 by 10 into 60 will be 6 plus 1 by 15 into 60 will be 4 minus 1 by 12 into 60 will be 5 equal to C. So I will get 6 plus 4, that is 10, 10 minus 5, that is 5 by 60. So I will get 5 ones 5 and 5 2s equal to 1 by 12. So C totally takes 12 hours to empty the total tank. Okay. Here C is emptying the tank. That's the reason we are keeping negative sign for C. And also we are sending this C to the right hand side and 1 by 12 to the left hand side. So we will get 1 by 12. That is C takes totally 12 hours to empty the total tank. Okay. Now let's see how LCM or units method works. They are saying A plus B plus C can complete the total work in 12 hours. Okay. And A can fill the total tank in 10 hours. And B can fill the total tank in 15 hours. Okay. This is hours and this is units. So what is the total amount of work to be done? That is LCM of 12, 10 and 15. That is 60 units. Okay, this is the total amount of work to be done. Then A plus B plus C is completing in 12 hours. So 60 by 12, that is 5 units per hour. A plus B plus C is completing 5 units of work per hour. In the same way, A is completing in 10 hours. So 60 by 10, that is 6 units of work. In the same way, B can complete in 15 hours. So 60 by 15, that is 4 units of work. Now if I substitute A and B from the A plus B plus C, I will come to know what is the total time taken for C alone to empty the tank. Okay. Since the C is emptying the tank, I am keeping negative sign for the C. So I will calculate this so that you can understand. See here, if I substitute A and B's value in the C, I will come to know what is the total time taken for C alone to empty the tank. So A plus B minus C equal to 5 units per day. Okay. Since C is removing the work, I am keeping negative symbol for the C. Okay. C is here emptying the tank. That's the reason I am keeping negative symbol for the C. So A plus B minus C is 5 units per day. So if I substitute this A and B's value in the A plus B minus C, I will come to know what is the total time taken for C alone to empty the tank. So I am substituting A and B's value. So I will get 6 plus 4 minus C equal to 5 units. So if I send this C to the right hand side and 5 to the left hand side, I will get 10 minus 5 equal to C. That is 10 minus 5, that is 5 units per hour. So C is emptying 5 units of work per hour. So to complete this 60 units of work, C takes 60 by 5, that is 5 ones 5 and 5 twos equal to 12 hours of time. So to complete this total 60 units of work, C takes 12 hours of time. Okay. Now let's see the sixth problem. They are saying that pipe A, B and C releases 3 different solutions, H2SO4, HCl and HNO2. These 3 pipes can fill the empty tank in 15 minutes, 25 minutes and 45 minutes. After 5 minutes, all the pipes are closed. Now what is the ratio of HNO2 in the mixed solution? So we need to find out what is the ratio of HNO2. So they are saying that pipe A, B and C can release the solutions H2SO4, HCl and HNO2. Okay, and also they are saying that A can fill the tank in, that is 15 minutes, and B can fill the tank in 25 minutes, and C can fill the tank in 45 minutes. So A's 1 minute work will be 1 by 15, B's 1 minute work will be 1 by 25, and C's 1 minute work will be 1 by 45. So they are saying that A, B, C and are released for 5 minutes. After 5 minutes, all the pipes are closed. So we need to find out what is the 5 minutes work for A, B and C. Okay. Now A is working for 5 minutes, B is working for 5 minutes and C is working for 5 minutes. So A is working for 5 minutes and also B is working for 5 minutes, that is 1 by 25 into 5, and also C is working, that is 1 by 45 into 5. Okay. Now here A is working for 5 minutes, B is working for 5 minutes and C is working for 5 minutes. So we will get 5 ones, 5 threes, 5 ones, 5 fives and 5 ones, 5 nines. So the ratio of A's work done, B's work done and C's work done is 1 by 3 is to 1 by 5 is to 1 by 9. Okay, actually this is the ratio of work done by A, B and C for 5 minutes. Okay, here they are saying A is working for 5 minutes, B is working for 5 minutes and C is working for 5 minutes, and after 5 minutes all of 3 are closed. Okay, so up to 5 minutes these are the work done of A, B and C. So we will get, if we take LCM, that is 9 4 36 and 9 5 45 will be divisible by 5 and 3. So the LCM will be 45. So 1 by 3 into 45 will be 15 is to 1 by 5 into 45 will be 9 is to 1 by 9 into 45 will be 5. So the ratio of work done of A, B and C is 15, 9 and 5. So in the mixed solution there are 15 parts, 9 parts and 5 parts. So there are totally 15 plus 9, that is 24, 24 plus 5, that is 29. Okay, so there are totally 29 parts in the mixed solution. So out of 29 parts we need to find out what is the ratio of HNO2. That is the solution released by C. Okay, here the solution released by C, that is only 5 parts. Okay, out of 29 parts, C solution, that is HNO2, is only 5 parts. Okay, this is the answer, that is 5 by 29. Now let's see how LCM or units method works in the same problem to solve it. Okay, so they are saying that A can fill the tank in 15 minutes, B can fill the tank in 25 minutes and C can fill the tank in 45 minutes. Okay, these are the time taken, okay, and these are units per minute. So the LCM of 15, 25 and 45, that is 15, 25 and 45. So I will get 5 threes and 5 fives, 5 nines, 45 and 3 ones, 3 fives, sorry 5 is at and 3 threes. So 5 3 15, 15 5 75 and 75 twos will be 90 and threes will be 150 and threes will be 225. So this is the total amount of work to be done, that is 225 units. So A is completing 225 units per 15 minutes. So per minute A is completing 225 by 15, that is 15 tens 150 and 15 into 15, yeah, 15 units of work per minute. And B is completing 225 by 25, that is 25 into 10 will be 250 and that is 25 less and 9 minutes, 9 units of work. Okay, C is completing 225 by 45, that is 45 twos 90 and 4s 180, so 5 units, 5 units of work. So A is completing 15 units and B is completing 9 units and C is completing 5 units of work per minute. So they are saying after 5 minutes all of them are closed. So up to 5 minutes A, B and C, all of them are open together. So A is completing 15 units per minute. So A is completing 15 into 5 per minute, that is 15 units per minute working for 5 minutes. Okay, A is completing 15 units per minute. So for 5 minutes A is completing 15 into 5. In the same way B is completing 9 into 5 and C is completing 5 into 5. Okay, so we will get 15 into 5, that is 75. 75 is to 9 into 5, 45 is to 25. So if I cancel with 5 here, 5 ones 5 and 5 5s 25. So 5 9s 45 and 5 5s 25. So 15 is to 9 is to 5. So this is the total amount of work done by A, B and C for 5 minutes. So for 5 minutes there are 15 plus 9 plus 5, that is 15 plus 5, 9 will be 24 and 24 plus 5, that is 29 parts in the solution. So for 5 minutes A released 15 parts of solution, B released 9 parts of solution and C released 5 parts of solution. So in the total solution there are 29 parts. For H1O2 that is released by C here. Okay, H1O2 is the released by C here. So out of 29 parts, H1O2 solution is 5 parts. Okay, out of 29 parts, H1O2 solution that is released by C is only 5 parts. So 5 by 29 is the answer for this question. And this is the way of solving the problems of pipes and cistern in normal and also LCMR units method. And the only difference is between the time and work and also pipes and cistern is, in pipes and cistern whenever there is a removing work or emptying the tank, we will keep negative symbol for that particular person or particular tap. Okay, that was the only difference, and the remaining all are same, and also all our methods also same in solving the problems. So if you are able to find out which is emptying and also which is removing the work, you can solve the problems very simply. And that's it for this video. For more tutorials like this, please subscribe to the channel. Thank you.